Okay, and last but not least, in the input section here, we have scene color and texture. So you can see here we've got this slightly glowing kind of material sphere happening, and this isn't just using the emissive. What it's doing is it's capturing the scene. So scene color here, what this will do is it'll give us an appearance, or give us what the material is rendering behind. So here we're set to a translucent material. As we saw with the depth buffer, translucent materials don't write to the depth buffer, and so because of that we can access the scene color behind our material. And so here I haven't used opacity to fade my object out. What I'm doing is I'm actually just rendering the sphere with the same material, the same colors, the same pixels as what's behind. And there's a very faint circle here, I don't know if you can see that, just at the edge of the sphere. That seems to be something to do with the temple AA. That's interesting. So what that means is we can take that color and we can make it darker if we wanted to do some kind of darkening, or we can make it brighter if we want to do some kind of lightening. And this can be used for lighting kind of fakes. So you could have a glowing particle effect or a glowing fire or a torch, something like that, and then rather than actually doing a light, you could use a scene color light to lighten things up, and that might work. It might be a little bit more cost effective. Similarly, we've got screen position, and what this gives us is our UVs based on our screen position. We looked at those already, and if we use that in our scene color, well, what we can do is we can add a little bit. So if I go in here and add a little offset, I'm just brightening it up. If I add a really small amount, you can see we've offset our UVs, so we can create kind of fake distortion effects. If I just quickly take a, let's not do that, let's do a texture. I'm going to do a quick noise. Let's use a normal. I should maybe have a setup for this, but there we are. Let's multiply that by, let's do the red channel. So a very small amount of distortion, and let's do it in the y-axis, and we get kind of a heat haze type effect. So I put my glow parameter back to 1. So this isn't using refraction, not using the refraction input, but it's a very similar result. What I'm doing is I'm taking the background pixels, rendering them to the plane, but with some distortion happening as well. And so a very small amount of distortion and a very slow moving normal map creates a nice result for sort of refractive things like this. Note, if you layer multiple ones of these up, you can get some errors, either this one or of refraction, but not a bad result using this scene color. Quick note why I've used a normal map here. Normal maps have positive and negative values in, and so by using a normal map, you're pushing information left and right or up and down at the same time. It just works quite well for distortions such as this. It doesn't really matter if I use just a normal noise. Let's say that one. We're still going to get a similar kind of result. So it depends what you're using here, but that's why I used a normal map in the other one. Okay, so that's scene color, capturing the information of the scene behind that we can then either make glow or darken, whatever we need, or we can just distort as well. Similarly, we have this one here, scene texture. This gives us access to all the different render buffers, but it's only useful for post-process. So if I plug in directly in here, it's going to give me an error. Oh no, fine, it is rendering through. And so that's taking the scene normal environment, so what's behind our plane, taking the world normals for it and rendering it to that plane. And so now you can see the normals of what's happening, but it's not the normals of this object, it's the normals of the objects behind. And you can see some things happening there. And so again, mostly used for post-process, but there are times when you might want to access the various render buffers in there. If we do scene depth, that should work. Okay, well, it's getting very, very high values. Let's just divide by a large value as well. I don't know. It's a very arbitrary value. And there we are. We can see our depth buffer. Looking through the sphere, we get to see our depth buffer. And probably want to clamp that. We're getting some very high values on the sky. But hopefully you can see that working through quite nicely. So some really interesting effects you can do with that. Grabbing hold of the different parts of the render buffer in your material as such. Okay, right, I think that is it for the input data section of this course. We've covered really quite a lot. Stuff that's specific to individual objects, so object position scale, more per pixel and per object data, vertex colors, very useful either imported or painted, custom primitives as an alternative to the material instance system, two-sided materials, two-sided signs to fix up some errors that they cause, pixel and vertex normal for doing calculations, time for animations, camera-based things, or depth-based, which is still camera-based really, but distance from camera, all sorts of interesting data. And the more stuff we can bring into our materials, the more we can then adjust that and use that and build things that are responsive, or fake things like reflections that are expensive. So a lot of useful stuff in here. In the next section, we're going to be having a look at just levels to UVs. And then finally we'll have a quick look at functions as well. So a lot that can be done in material with UVs, worth dedicating a whole series to it, I think. And then functions will be sort of an overview of the things we're going to make in the second half. Okay.